Hey guys, today I'm going to teach you all about fractional unit rates. By the end of this lesson, you'll be able to calculate unit rate in word problems by dividing rational numbers. So we've done unit rate, now we're going to do a unit rate with fractions. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. So let's just review what we know already about unit rate. Unit rate is a specific comparison between two quantities. So for example, if I was going to look to buy a vehicle, I might want to compare their miles per gallon rate. If I know which one has the better miles per gallon or gets more miles per gallon, I might buy that vehicle. That might be the better buy for me. So, that being said, a unit rate is not just for miles per gallon. A unit rate is the value when the denominator, and just remember that means the bottom of your fraction, is 1 or the amount per 1. For example, I could think about miles per hour. How many miles per hour can I go? How many times can I click a button? And I do it in like 10 seconds, and I want to know what my rate is per 1 second. So I can do how many math problems I can do in 40 seconds. Then I want to see how many math problems I can do in 1 second. I mean, it's everything per 1. It's always going to be per 1. So it is the same value as the constant of proportionality, and it can be represented with fractions. So I just added a few more examples here. So let's go ahead and take a second. Let's practice finding the unit rate of the following problems. You should already know how to do this, so go ahead and take a second, pause the video, and fill out all 3 of these. And press play when you're ready to check. Okay, so you should have just tried these. It said practice finding the unit rates. The unit rate means divide. When you see unit rate, that means divide. So whenever you see 78 sit-ups per 2 minutes, you're going to do 78 divided by 2. That gave us 39 sit-ups per 1 minute. Since it's per one thing, that means it's a unit rate. We can use the unit rate to make comparisons and to predict. We know that Nick is doing sit-ups at a rate of 39 sit-ups per 1 minute. It's the same process for number 2. He can do 42 push-ups in 3 minutes. So 42 per 3 is 14 push-ups per 1 minute. This is the better way to look at this because we use unit rate to compare and make predictions. I know now if he did it in 6 minutes, I could multiply 6 by 14 and get my answer. And then the last one is really easy because it's already given to you. 40 jumping jacks per 1 minute is already the unit rate since it's per 1 minute. So you could have thought of this as 40 divided by 1, but you really should have realized this is already a unit rate. So what you should have noticed about all of these is that they're all per one thing. And in this case, it was per minute, but the unit rate can be per one anything, but it's always per one thing. That's the unit rate. So what we're going to get into today is whenever we have fractional unit rates. So before we get started on what fractional unit rates might look like, let's go ahead and start practicing multiplying and dividing fractions. We need to review these operations with rational numbers before we get into the application today. So go ahead and take a second. You have 4 practice problems. Go ahead and try these 4 practice problems by yourself. Pause the video and press play when you're ready to check. Okay, so for number 1 here, I am looking at a mixed number times 6. So I don't ever multiply or divide or add or subtract. I don't do anything with mixed numbers. I always want to make them improper fractions first. There's multiple ways to do this. However, I would make it an improper fraction first. So you do that by doing the around the world. Multiply and then add. So 2 times 1 is 2, plus 1 is 3. Your new fraction for 1 and 1/2 is 3 halves. You're multiplying that by 6. And remember, every number that's a whole number is just over an invisible 1. When you multiply fractions, you multiply straight across. So 6 times 3 is 18. 2 times 1 is 2. You can simplify that because 18 divided by 2 is 9. So your answer would be 9. Let's do the same thing for number 2. We don't multiply with mixed numbers. I like to multiply with improper fractions. So that means I want just a top and a bottom. So I want to multiply and then add. So I'll go around the world. 2 times 2 is 4, plus 1 is 5. So I have 5. Keep the denominator 2. This says divide by 6. Every number has an invisible 1 underneath of it. So this is a division problem with fractions. And you should be thinking to yourself, no, I never divide fractions. You multiply by their reciprocal. Or keep, change, flip. That's how we think of them. So you keep the first number. You change the divide to a multiply. And you flip 6 over 1 to 1/6. So your new problem should look like this. So all I did was keep, change, flip. I never divide fractions. I multiply by the flip. So you multiply fractions straight across. So 5 times 1 is 5. 2 times 6 is 12. So your final answer is 5/12. Let's look at number 3. It says 2 2/3 times 1/2. Again, we have a mixed number. I don't mess with mixed numbers, so I'm going to do the around the world. 3 times 2 is 6. Plus 1 is 8. Plus 2 is 8. 8 over 3, because I keep the denominator, times 1/4. I can multiply fractions, and I multiply them straight across. 8 times 1 is 8. 3 times 4 is 12. And then you always simplify if you can. So you simplify by thinking what number goes into both of these. I know that 4 goes into both of them. I know that 4 goes into 8 2 times, and I know that 4 goes into 12 3 times. So 2/3 is your fully simplified answer. Let's look at the last one. I have another mixed number. I don't mess with mixed numbers. I want it to be improper fractions. So 4 times 1 is 4, plus 3 is 7. So I have 7 over 4 divided by 2/3. Remember, when you see a divide fractions, you should think, I never divide fractions. I want to multiply by their reciprocal. Reciprocal just means flipped fraction. So I keep the first number, so 7 over 4, change the divide to a times, and then I flip the 2/3 so that it's 3 over 2. Then I multiply straight across. So I get 21 over 8. And then it's a improper fraction. Now we want to make it a mixed number. Now that we're at the end, I know 8 goes into 21 2 whole times, and it has 5/8 remaining. So 2 and 5/8 would be your final answer for that one. So what does all that have to do with unit rate? So here's your examples in a new table. The fitness test results of other students are shown below. Determine their unit rates. So here's the fitness test results for some other students. 1.5 miles in 15 minutes, 2 miles in 2 minutes, and 2 1/3 miles in 20 minutes. You should notice that all of these rates are fractional. So all of these have fractions in the unit rate except for 2 miles for 12 minutes. So what we want to do first is we look at the table and we see x's and we see y's. So let's think back to what we know about constant of proportionality, proportional relationships, tables, and graphs. When we look at this, we have inputs and outputs. We put in a certain thing to get out a certain thing. Also, if I was going to graph this, x would be my x-axis, so it would be the flat one. So which of these two, minutes or miles, would be your x? What do you put in and what do you get out? You put in minutes to get out miles. So just above or below your x and your y, I want you to label what those are. X is going to be your minutes and miles is going to be your y. And if you look at the problem here, 1.5 miles in 15 minutes, it looks like it's written backwards, but that's how you would say it. You would say 1.5 miles in 15 minutes. This is like written like it's supposed to be, a unit rate, y per x. Unit rates are always y divided by x. So it's always the y, miles, x, minutes. So I'll work through this first one with you. Be careful just to make sure that you write 15 here and you write 1.5 here. This next column is asking you for your y over x. Your y over x is your unit rate, but it's just going to work it out a little bit for you. So we're going to show our work in this box. So our y divided by x is 1.5 divided by 15, which was our x. So I have a mixed number divided by a whole number. To find my unit rate, I'm going to need to work that out, and I want to do it without a calculator. So go ahead and pull out a dry erase marker and board, or pull out a piece of paper and a pencil, because you're going to need to work this out by hand. So you have 1.5, and you have divide by 15. I'm just going to do my work here in the corner, but you should do yours on a separate sheet of paper to stay organized. The first step is going to be to make this mixed number an improper fraction. So 2 times 1 is 2, plus 1 is 1. So I draw my arrows just to show my work. I times and then add. I always just do that to show my work. You don't have to put that on your paper if you know that 2 times 1 is 2 plus 1 is 3. But you should have 3 halves, and then you have this 15. It's over and divisible 1. So remember, I never divide. I multiply by the flip. So 3 halves times 1 over 15. It's an equivalent expression. These are the same things. This is just easier for us to do. So 3 times 1 is 3. 2 times 15 is 30. So I have 3 over 30 as my rate. But remember, I can simplify. 3 goes into 3 one time, and 3 goes into 30 10 times. So I think what number goes into both of them? 3 goes into both of them. So my final answer is 1/10. So I have 1/10 as my unit rate. So you might be thinking, isn't it supposed to be per one thing? Yes, it is. It's 1/10 of a mile. So you always want to label per 1 minute. So this looks ugly and confusing because there is a fraction within a fraction. However, this is what we're getting into today because not every number is perfect. Sometimes we do 1.5 miles in 15 minutes. Not every number is a whole number. So this is a correct answer. 1/10 of a mile in 1 minute. Take a second to pause the video, try the next two, and then press play when you're ready to check. So 12 minutes, 2 miles, abbreviated miles and minutes. You want to use the y divided by x formula for this. So you want to do 2 over 12. And then it is the same thing as 1/6. One mistake that I see and I almost made myself is that people might write 1 mile per every 6 minutes. Is that true? No, that is wrong. We did y divided by x to find our unit rate. This is actually 1/6 of a mile. That's per 1 minute. It's not 1 mile for every 6 minutes. That would be a really, really fast mile for this. It's 1/6 of a mile for every 1 minute. This is the unit rate, so it's always over 1. Let's go ahead and look at the last one. 20 minutes, 2 1/3 miles. I'm going to divide my y divided by my x. This is our y. This is our x. So I'll write this as 2 1/3 divided by 20. But I don't want to keep it like this. I want to change this mixed number to an improper fraction. So 3 times 2 is 6, plus 1 is 7. So 7 over 3. I don't want to divide my fractions. I want to keep the first number, change the divide to a times, and flip that 20 over. So it's 1 over 20. And I end up with 7 over 60. So 7 over 60 is my y divided by my x, and it's fully simplified. There's no number that goes into both 7 and 6. So over here for the unit rate, it's 7/60th of a mile per 1 minute. So here's 4 practice questions for you to try by yourself, and then we will go over these in class. All right, guys, that's it. If you made it to the end of this video, please comment how many points do you think Michael Jordan scored per game in the comments. Today we went over fractional unit rates, so now you should be able to calculate unit rate in word problems by dividing rational numbers. So go ahead and go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.